Yes, sir. Hello.
এই আমার কথা শোনা যাচ্ছে?
হ্যাঁ স্যার, শুনতে পাচ্ছি।
আর স্ক্রিনটা দেখা যাচ্ছে তো?
হ্যাঁ স্যার।
ওকে, ঠিক আছে। আচ্ছা, কারোর যদি কোনো কিছু কোশ্চেন জিজ্ঞেস করার থাকে তাহলে হ্যান্ড রেজ করবে, আমি তাকে আনমিউট করার অপশন দেব। ঠিক আছে? ওকে, today we'll start with trip current during the dielectric voltage withstand test. So what is the trip current? Trip current is basically when a dielectric breakdown occurs, the loss of insulation materials, dielectric breakdown when dielectric breaks, when the insulation resistance, insulating materials resistance causes the current to go from a low dielectric current level to a much breakdown current, much higher breakdown current. Means, say suppose if we place a insulator between a voltage source and say suppose this is a insulating material. Okay, normal condition what will happen? Insulator is basically offer very high resistance, and if you gradually increase the voltage at certain voltage, that insulator breaks. Insulator breaks means that initially that insulator offering very high resistance to oppose the flow of current, but if you gradually increase the voltage at certain voltage, insulator breaks. Insulator breaks means that resistance given by the insulating material will be less, so some current will be conduct through this insulating material. That is basically called the dielectric breakdown. Okay, so that is written here that resistance cause the current to go from a low dielectric current level to a much higher breakdown current. Normally insulator offers very high resistance, so it very low value of dielectric current is flowing at the normal voltage level, but if you gradually increase the voltage, then at certain voltage that resistance offering by the insulation will be gradually decreases, means that more current will be flowing through the insulating material, and at certain voltage there is a collapse of that collapse, in that sense that resistance offering by the insulating material is very low. You can say, you can consider that as a equivalent conductor at certain voltage level. Okay, so change in level of dielectric current has traditionally been monitored by a current sensitive circuit which is called the trip circuit. Generally we want to observe that what is the change of dielectric current, and that is basically monitored by a current sensitive circuit which trips out the test equipment when the current exceeds the test equipment trip sensitivity setting. All of you know from the circuit breaker concept point of view, if you gradually increase the voltage at certain voltage level, circuit breaker open by sensing that or certain current level, that circuit breaker opens, depending upon the what is the setting of the relay. Okay, a relay is basically setting a particular, if it is a current operated relay, say for if we set 5 ampere current, up to 5 ampere current, that there will be no such operations involved of circuit breaker. But if due to uncertain changes in network condition in that sense, if the fault is occur within the system, then there is a change in network condition. So by sensing this, if current flowing through the circuit is more than the specified current, then the circuit breaker operates. So here also the same point of view, that generally in trip circuit we set a particular current level. If a particular dielectric material breaks, or in case of certain dielectric material, when it is operating normally, but at for elevated voltage, some more current will be flowing through the insulating material, and that current rating is more than the current setting in the trip circuit, then the trip operation done. So this is basically called the trip circuit or trip current during the dielectric voltage withstand test. Now this approach has the significant advantage of being simple and inexpensive and has been used for many years. What is the approach? By sensing that current flowing through the circuit, either we can assume that there is a breakdown occur, or maybe that current is flowing through the circuit due to the higher voltage level. So this is the normal thing. However, this method works reasonably well. A closure analysis reveals potential limit to its use. Okay. Now, sometimes false failures. What is the meaning of false failure? So generally, use of a trip current setting to determine the dielectric breakdown is basically assumption that the current above the trip setting is indicative of dielectric breakdown. But it is not true for. Insulating material. If it is operated at higher elevated voltage, then this current flowing through the insulating materials also increases. But this is not a breakdown of the insulator. This is the normal case. So that is the thing. If you use a trip current setting to determine the dielectric breakdown, we can assume that current above the trip setting is indicative of dielectric breakdown. But this is true in most of the cases, but there are certain instances in which a current above the trip out threshold is not indicative of the breakdown at all. It may actually be reflective of the natural dielectric current of the tested device at a elevated voltage. Okay. Who is Prabhat Chandra Das? Prabhat Chandra Das, you have any queries? Okay. So this is the false indications. The dielectric, there is no such breakdown, but maybe there is a current is more than that trip voltage. So due to that, it may actually be reflective of the natural dielectric current of the test voltage. Okay. Now, so there is a dilemma between that whether the breakdown is occur or not. So trip out might indicates the dielectric breakdown. In most of the cases, we set the trip current in such a way. If there is an abrupt change in current value, or you have to set that trip current trip circuit setting in such a way that it must indicates that breakdown. So you have to set that trip current setting at very higher value, but it might merely indicate the dielectric current above the trip current setting, but this is not a failure condition. Okay. So this uncertainty may lead to the test result deemed unacceptable when the result actually masks a favorable outcome. Favorable outcome in that sense, so whether it is a breakdown or whether it is the normal condition. So you have to set that trip current setting in such a way that it must if the current flowing through the circuit is more than the trip current setting, then this should be for the breakdown voltage, or this is the indication of the insulator breakdown. But if it is the normal case, say for certain higher voltage level, the current flowing through the dielectric material is gradually increases, but if you set the trip current setting in such a way that is exceeds that value, so for that case, some of you may have considered that the case that is the case of breakdown, but generally it is not happen for all the cases. It may be the normal current flowing through the circuit due to the higher voltage level. Okay. So this is the setting. Here you see the two waveform. In one waveform, if you set the current setting in that way, so if it exceeds this point, so we can consider that as a breakdown. But this gives a false failure, because it is not actually the breakdown of the insulator. It is the normal current gradually increases with the increasing voltage level. But if you setting the trip current in such a way that if your trip current setting at higher value, now at certain point of time, if it exceeds a certain voltage level, now there is a total collapse of the insulating material. So current is abruptly increases. So that is the thing we want to mention here, that if your trip current setting in such a way that it can in a particular condition, if current exceeds the trip current setting, so we can consider that is the case of the breakdown of the insulator. So this is basically the proper way of setting that trip current. And sometimes if you set the trip current at lower value, maybe at certain voltage level, that current flowing through the dielectric exceeds that trip current setting, but it is the normal case of the insulating material. So this is the case of the normal, and this is the case of the abnormal situation or the insulating material breakdown. So this is the abnormal situation, this is the normal situation. But someone sets that trip current in that fashion, so a normal situation can be considered as the breakdown phenomena or breakdown of the insulation. So, but if someone said that current setting in that manner, so we can definitely conclude that if current flowing through the circuit exceeds that trip current setting, so there is a chance of the breakdown. Okay. So dielectric test intended to evaluate the insulation system. No limit is specified for the dielectric current. So there is no current trip out, or you can say there is no correct trip out current setting for the determining the failure. So from the concept from previous experience, if you know more or less that insulating material breaks at that certain voltage level, so according to that knowledge, prior knowledge, you can set that trip current in such a way that when the current exceeds through the circuit, it exceeds the trip current value, that must indicates that breakdown voltage. So that is the prior knowledge or previous expertise is necessary for setting the trip circuit. In practice, the only valid determining criteria for the failure is breakdown. Precise value of dielectric current which flow is unimportant. What is important here? The dramatic increase in the dielectric current indicating that the insulation breakdown has occurred. Okay. So to summarize, the tripping of the dielectric tester only signifies that trip current setting of the tester has been exceeded. Therefore, this result should not be automatically interpreted to mean that breakdown has occurred and further testing or evaluation should be conducted. Okay. So before going to that next slide, now if you have any questions or any queries, now you can ask me if you have any questions regarding this. কোনো কোশ্চেন থাকলে হ্যান্ড রেজ করো আপ টু দিস ডিসকাশন। যদি কারো কিছু জিজ্ঞাসা থাকে তাহলে বলো, নাহলে আমি নেক্সট ডিসকাশনে যাব। কারো কিছু জিজ্ঞাসা থাকলে বলো, আনমিউট করে জিজ্ঞেস করতে পারো। আনমিউট করার অপশন দিয়েছি, তোমরা যে কেউ জিজ্ঞেস করতে পারো। আর যদি না কিছু থাকে তাহলে আমি নেক্সট স্লাইডে যাচ্ছি। Okay, so you have no such questions. Now we can perform the testing based on AC as well as AC supply as well as DC supply. Here we want to show whether the AC or DC, which one is more beneficial for the dielectric testing. Okay. The objective of the dielectric testing can be met with DC. Just now I mentioned that for testing, dielectric testing can be done both DC as well as AC voltage. Many product safety includes DC voltages in their dielectric test. There is a definite reason behind that. I will discuss that the reason after this point. When the testing with DC voltage, the meter voltage must be set for a voltage equal to the 1.414 times the AC test voltage. But all of you know that DC voltage, which is equals to the what? Equals to the, say suppose if we test for a particular AC voltage and someone is tested for a DC voltage, that DC voltage level is equals to the AC peak voltage. And AC peak voltage is basically what? 1.414 times the AC RMS voltage. So that is the main, they mention that meter voltage must be set for a voltage 1.414 times the AC test voltage, since the AC voltage measurement is an RMS value. Okay. What is the advantage? With the DC test, steady state dielectric current will be much lower. Why the current will be much lower? Because DC, in case of DC test, that insulation or capacitance offered by the insulation, that is basically charged only once. Okay, so this occurs at the beginning of the voltage applications. If the test voltage is raised slowly, the charging current will be low, and once the test voltage stabilizes, there will be very little current flow due to that charging. This is an advantage of that, you can say, compare with the AC voltage, because the trip out limit of the dielectric tester can be set lower without causing false alarm. Now, in case of DC, you will be face some problem if the voltage is ramped up very quickly. So the capacitive charging current may create a false failure, because if the voltage is ramped up quickly, so charging current drawn by the capacitive is more, so there is a chance of the false tripping. Trip out during DC voltage ramp up must be examined to determine if the cause of the trip out is normal charging current. For that purpose, you have to repeat the test with a double ramp time, may provide a simple testing solution. Okay, just a minute. Okay. So that is the thing. This is the advantage of the DC. Over AC, there will be less charging current, but sometimes if the voltage is ramped up quickly, so there is a chance of there is a chance of false failure because that capacitive charging current drawing from the DC source is more, and that may exceeds that trip current setting. Okay. Now, some product also contain that electromagnetic interference filter, so which may add capacitance. So if this type of circuit or this type of equipment having that electromagnetic interference filter, so that at capacitance, to accommodate this filter, the leakage current limit in some product safety standard is 3.5 milliampere. So say for this is the as a case study, say leakage current limit for some product is say 3.5 milliampere, but in case of AC, if you want to test with the help of AC voltage, so for that case that current will be 36 milliampere in case of AC RMS voltage. So that is the advantage of the DC. If you perform the test with the help of the DC test voltage, so for that case current is only 3.5 milliampere, but if you perform the test with the help of the AC, for that case current exceeds up to 36 milliampere. Okay. So with this heavy loading due to that more charging current in case of AC, some dielectric testers are not able to deliver enough voltage across the terminals to perform this test. However, if you use DC for supply that test voltage, that capacitive current is just its one-time charging current, and once the capacitor is charged, the dielectric tester requires only a small current load that the tester can easily supply. Okay, so this is you can say this is the advantage of the DC compared to the AC. In case of high leakage current limit, replacing the AC test with a DC test may be necessary unless the AC dielectric tester has enough capacity to deliver the test voltage under heavy current load. You can perform the test with the help of AC supply also, but AC supply having the capacity to deliver that high amount of charging current corresponding to that higher voltage. But most of the cases, if you perform the dielectric test with the help of DC, so that will be much more advantageous compared to the AC. But there is one disadvantage of the DC testing, which becomes evident at the end of the test. Once the DC testing has been completed, mind that if I use that AC supply, so there is a continuous charging and discharging of the capacitance which occur. But in case of DC circuit, once the capacitance is charged, it retains its charge. So after testing, you have to forcefully discharge the capacitance, so that because inherent capacitance of the device under test has been fully charged and now poses a potential shock hazard. So manually or by providing any automatic means, after testing, you have to do in such a way that after testing, that automatically or manually you have to discharge this test capacitance. So this is basically the advantage of the DC over the AC, but it suffers one disadvantage, that capacitor is charged throughout the capacitor is retain its charge after testing also. Manually or automatically you have to discharge this capacitance. Otherwise, it basically problems if someone laboratory people or someone by unknowingly if they touch the test equipment or test object. Okay, so there is a chance of get shock hazard by if this test object retains its charge. Okay. So now up to these discussions, if you have any doubt, you can raise your hand. কোনো ডাউট থাকলে বলো। এই চিরঞ্জিত।
হ্যালো স্যার।
হ্যাঁ বলো।
হ্যাঁ বলছি, আপনি বললেন যে ডিসির ক্ষেত্রে ওটাকে আলাদা করে ডিসচার্জ করতে হবে আফটার টেস্ট। তো
হ্যাঁ
কিন্তু স্যার যদি ব্রেকডাউন হয়ে যায় ইনসুলেটরটার, তাহলে কি ওটাকে ডিসচার্জ করতে হবে আলাদা করে, নাকি ওটা শুধু যদি মানে ব্রেকডাউন না হয় তখন করতে হবে?
হ্যাঁ ব্রেকডাউন, দেখো ব্রেকডাউন হয়ে যাওয়া মানে ইফ দ্য আদার এন্ড অফ দ্য টেস্ট অবজেক্ট ইজ কানেক্টেড টু দ্য গ্রাউন্ড, দেন অটোমেটিক্যালি দ্যাট ইজ ডিসচার্জেস। বুঝতে পারলাম? যে ধরো ইনসুলেটরটা প্লেসড আছে দুটো ইলেকট্রোডের মাঝখানে, তুমি একটা এন্ড কানেক্ট করেছো হাই ভোল্টেজের সঙ্গে আর একটা এন্ড কানেক্ট করেছো গ্রাউন্ড। এবার যদি ব্রেকডাউন হয় তাহলে তো ওই ক্যাপাসিটার থাকলো না, কন্ডাক্টর হয়ে গেল, ও চার্জটা ডিসচার্জ করে দেবে থ্রু দ্য গ্রাউন্ড। কিন্তু যদি এরকম হয় যে জাস্ট ইট উইথস্ট্যান্ড দ্যাট ভোল্টেজ at test voltage level, so for that case you have to manually or automatically you have to discharge the capacitance. Otherwise if your circuit is completely off, means supply circuit যদি অফ করে দাও তাহলেও দেখা যাবে যে ওই ক্যাপাসিটরটা চার্জটা রিটেন করে আছে। সেটা ডিপেন্ড করছে যে ক্যাপাসিটরটা কতটা হচ্ছে যে তাড়াতাড়ি মানে চার্জটা ডিসচার্জ করে। ঠিক আছে অর্ণব, বোঝা গেল?
স্যার
হ্যাঁ বোঝা গেল?
হ্যাঁ স্যার, আমি আনমিউট করতে পারছিলাম না।
আচ্ছা আচ্ছা, না সে তোমাকে করতে হবে না, আমি করে দেবো। আর কারোর কিছু জিজ্ঞেস থাকলে বলো।
স্যার
আর কারোর কোনো কিছু যদি এই আপ টু দিস ডিসকাশন কোনো ডাউট থাকে বলো, না হলে আমি নেক্সট কোশ্চেনে যাব। আচ্ছা সবাই হচ্ছে এই হ্যান্ড রেজ করবে তাহলে আমি বুঝে যাব। ঠিক আছে
স্যার
ওকে, আপাতত আমি ধরে নিচ্ছি যে আর কারো কোনো আপ টু দিস ডিসকাশন কোনো ডাউট নেই। নাও you have to measure whether the insulating material provide that sufficient insulation or not, or you have to choice whether the insulating material is good or bad. Now what is good insulation? There is no such definitions behind that good insulation. No such definitions. Means good insulation means what? Insulating materials, why we use that insulating materials? Generally we use that insulating materials to provide or to isolate the current conducting part, maintain a different potential. So this is the main purpose of that insulation. There is to prevent the current flow between the two different two conducting part which are maintained at different potential. It may be light, or one of the may be light, one of the may be ground, or maybe the conductor maintained at different potential. Or in order to isolate between the, when you are supplying the power, in order to provide that insulation between that phase conductor, because phase conductor are maintained at different potentials, so provide the insulation between them. So there is a no you always we have to our demand is that there is no such flashover occur between the two adjacent conductors. So for that purpose you have to provide sufficient insulation. So you have to select a particular insulating material. If that insulating material is capable to offer the high resistance between that two live conductor maintained at different potential, so we can say this is a good insulation. Okay, so no insulation is perfect. All of you know there is no such ideal insulator is there. So you can say no insulation is perfect, that is such infinite resistance. It is not practical possible. Theoretically you can say the insulating material having infinite resistance, but practically it is not possible. So some electricity does flow along the insulation or through it to the ground, but such a current may only be the millionth of an ampere or 1 microampere, but it is the basis of the insulation testing equipment. Okay, and what is good insulation? Obviously good means a relatively high resistance. When an insulating material offer very high resistance to the current, so we can say this is a good insulating material or good insulation. So to describe the insulating material good would also mean the ability to keep a provide a high resistance. So a suitable way of measuring resistance can tell you how good the insulation is also. But again, for say declaring that particular insulating material good or bad, so you have to measure the what is the insulation or what is the insulating resistance offered by this insulating material. So measurement is required. Now what makes insulation go bad before measurement before measuring the insulation resistance? Now you have to understand, say suppose a brand new insulating material generally good in conditions except that manufacturing defect, but what are the reasons? So the insulating material gradually degrades its quality, or what characteristics or what are the point that makes the insulation go bad, means it degrades the property of the insulating material. Okay, what are the points? All of you know these points, that there are several points. What are the several points? Several points are that in the presence of excessive heat or cold, dirt, oil, corrosive vapors, moisture from the processes, or the humidity on a muggy day. So that is basically the major cause of the insulation go bad. Okay. Now, how you have to measure the insulation resistance? Okay. Now I have to unmute all of you. Just you try to give answer how you measure the insulation resistance. বলো, আনমিউট করতে পারবে? ইনসুলেশন রেজিস্ট্যান্সটা আমরা কিভাবে মেজার করব? হ্যাঁ অর্ণব বলো।
Hello.
Hello.
হ্যাঁ বলো।
Sir, by using the Megger.
যে কোনো একজন করে বলো, ইউজিং দ্য মেগার।
Yes, yes, sir.
আচ্ছা, মেগার দিয়ে ইনসুলেশন রেজিস্ট্যান্স মেজার করবে, তাই তো?
Yes, sir.
ওকে, আচ্ছা। এবারে এই মেগারের কিরকম মেগারের রিডিং দেখে বলবে এটা ব্যাড না গুড? গুড ব্যাড কিভাবে কমেন্ট করবে? হ্যাঁ, অনেকে হাত তুলেছে ওয়ান বাই ওয়ান। হ্যাঁ, কে বলছো? বিশ্বজিৎ কুন্ডু, দেবজ্যোতি নন্দী, সবাই হাত তুলেছো, বলো। সবাই নিজেরা আনমিউট করতে পারবে? আনমিউট করো।
স্যার বিশ্বজিৎ বলছি।
বলো।
ওই স্যার ওই ইনসুলেশন রেজিস্ট্যান্সটা যদি মোর দ্যান 15 মেগা ওহমের বেশি হয় তাহলে বলবো যে ঠিক আছে।
আচ্ছা, তাহলে বলবে ঠিক আছে। ঠিক আছে। আচ্ছা, বিশ্বজিৎ বললো। আর কেউ কিছু বলবে যারা হাত তুলেছো? সুজয় হাত তুলেছো। আর কিছু বলবে? বিশ্বজিৎ বললো যে হ্যাঁ ঠিক আছে, একটা যদি 15 মেগা ওহমের বেশি হয় তাহলে বলবো যে ইনসুলেটিং মেটেরিয়ালটা ঠিক আছে, কিংবা তার চেয়ে কম হলে তাহলে ভালো নেই। এটা হচ্ছে যে বিশ্বজিৎ বললো। আর কেউ কিছু বলবে? মেগার দিয়ে ইনসুলেশন রেজিস্ট্যান্স মেজার করা হয়, এ নিয়ে কোনো সন্দেহ নেই। তোমরা ফার্স্ট ইয়ারে মেগার দিয়ে হয়তো ইনসুলেটিং রেজিস্ট্যান্স মেজার করেছো, সেটা ঠিক আছে। তবে তোমাকে তো জাজ করতে হবে whether the value is providing good or bad, ঠিক আছে? আচ্ছা, এবার আমি একটু বলি যেটা বিশ্বজিৎ বললো। এমনি বিশ্বজিৎ ঠিকঠাকই বলেছে, তবে বিশ্বজিতের ক্ষেত্রে হচ্ছে যে একটা ডিপেন্ডিং ফ্যাক্টর হচ্ছে যে 15 মেগা ওহম a 15 mega ohm the good or bad? Obviously this is 15 mega ohm is a high resistance, but again this will be depends on the type of equipment, and generally what is the normal range of equipment, if it is 15 mega ohm or 50 mega ohm or 30 mega ohm. So you have to require a prior knowledge. Okay, that generally that insulating material for this type of equipment শোনা যাচ্ছে? Generally for 15 mega ohm we can this is not a thumb rule for every equipment, because for depending upon the voltage level, that insulating material quality is depends on this. So depending upon the voltage level, so we have to know what is the general insulation resistance value. But some of you have no such idea about what is the insulation resistance of that equipment. So for that case, better if you measure the insulation resistance at a periodic or regular interval, and if you compare the reading for different measurement, if it is showing constantly that a particular value, means that insulator quality is not degraded with time. So from that we can say that is a good or bad. But obviously if you have idea about that, in brand new condition this is the resistance offered by the insulating material, and what is the value obtained from the measurement, if it is closer to that insulation resistance offered by that material in new condition, so you can say that insulator is good condition. But generally in case of when the particular machine is in operation, during that time at regular interval or at periodic interval, at certain period of time, you have to measure the insulation resistance and you have to record that value, and after certain time if you check that record, and if there is a if that resistance value is maintaining at a certain constant value, so you can say that insulator condition is not degraded. But again, that constant value is in the lower side, so you have to think about that there is no further deterioration of the insulation, but you have to improve that condition of the insulator. So there is a chance of dust particle over the surface of the insulator, it may degrade that insulation resistance. So you have to clean, or you have to take care that what is the cause behind that lowering that insulation resistance value. Okay, so these are the things that is involved in case of measurement. But what you suggest that for measurement of insulation resistance, so we use that insulating resistance measurement device, or generally that according to the company, that is sometimes people also call this is a Megger, but Megger is basically an insulation resistance tester or insulation resistance measuring device. That according to the company name, generally we term that is a Megger. Now you see, good insulation at high resistance, poor insulation relatively low resistance. So this is basically the thumb rule for any insulating material. Good insulation at high resistance, poor insulation relatively low resistance. The actual resistance value can be higher or lower depending upon such factors as the temperature or moisture content of the insulation. That is, resistance decreases in temperature or moisture. So insulation, so you have to consider a insulation tester, which is a small portable instrument that gives you a direct reading of insulation resistance in ohms or mega ohm. For good insulation, resistance usually reads in mega ohm range. Okay, so insulation tester is essentially high range resistance meter with a built-in direct current generator. All of you know that when you use that insulation tester, we are tracing about that name, insulation tester. That, but if you all of you are commonly known as that the Megger, when you did your experimentation with the help of Megger, all of you know this is a direct current generator, there is a hand driven generator. You have to rotate that particular rotating part of this generator at a certain value by manual operations. So that is why that laboratory staff or laboratory teaching instructed you have to maintain a constant rotation. So there will be no such fluctuation of the voltage level. Okay. So this meter is a special construction with both current and voltage coils, enabling 2 ohms to read directly, independent of the actual voltage applied. So this method is a non-destructive. Without destruction of the insulating material, we can measure the insulation resistance. So this is a non-destructive method, and it does not cause deterioration of the insulation. Okay, and this is basically the pictorial view or schematic view of the typical test instrument for measurement of the insulation resistance. So this is a hand driven generator, and this is the handle. You generally rotate it during the experimentation. So this is a hand driven generator, and this is basically the insulating material placed between the electrode, and if you gradually generate that voltage with the help of this, and you have to connect that terminal across the where the insulating material placed, so you can measure the resistance by using this insulation tester. Now you see the generator can be hand cranked, hand driven, or line operated. It may be operated automatically to develop a high DC voltage. Say suppose there is a source. Okay, say this is a source. Now this source is connected across the resistance. Now if you generate some voltage, so what will happen? There is due to the presence of that closed circuit, some current will flow through the circuit. So generally, small current flowing through the circuit due to that high DC voltage, what the surface of the insulation being tested. This current usually at an applied voltage 500 volt, but there is a different current setting, a different setting of voltage levels are there in insulation tester or Megger with the 500 volt. This is the basic things, and you can measure that insulation resistance at higher elevated voltage up to 5 kilovolt. In our laboratory, in high voltage laboratory, we are having a Megger that must capable to measure that voltage insulation resistance up to 2.5 kilovolt at the interval of 500 volt. Okay, so there is a all of you maybe know that if you want to measure that insulation resistance of the insulating material, which is operated at very high voltage level, so for that case, if you perform the measurement of insulation resistance at very low voltage level, so that doesn't provide a good result, because that after applications of applied voltage, certain general phenomena which is occur inside the insulation insulating material, that is basically govern the insulation resistance. Okay. Now you see there is a picture that is the typical scale of the insulating tester. All of you know that side. If your needle is deflected in that side, means when it is close to infinite or close to that higher value, means that insulating material is in good condition. But if it is in lower side, so you can say insulator condition is not good. Okay. Now how to interpret resistance reading? So for that purpose, periodic testing is the best approach to preventing the maintenance of the electrical equipment using record cards. Periodic testing means at regular interval you have to measure the value of the insulating materials, resistance value of the insulating materials, and if you recorded that value, from that record you can conclude whether the insulator is good or bad. Whether you test monthly, twice a year, or once a year, depends upon the type of location and importance of the equipment. Say suppose a transformer, power transformer, so that is the very important equipment. So for that case, you have to test that insulating resistance measurement. You have to done for monthly basis. And suppose a certain voltage, certain equipment which is less costlier and less important. So for that case, you can perform the test once in a year or twice in a year. Now you should make this periodic test in the same way in each time. Same way in each time means you have to maintain that same test voltage level, same length of time, that is the application time also same. Also you should make the test which about the same temperature or correct them to the same temperature. You can, it is not possible to maintain the same similar temperature without the closed chamber. So suppose if someone perform the test at winter season and someone perform the test at summer season, that is not, that reference of measurement is not similar. They are not identical. So for transferring that winter result to the summer or summer result to winter, we incorporate some temperature correction factor. Okay. So record of relative humidity near the equipment at the time of test is also helpful in evaluating the reading and trend. Later sections cover temperature correction and humidity effects. Means when you are performing the test, that time you have to record both the temperature and pressure, also humidity. And if you want to compare all those results with same temperature, same humidity, with same reference, so you have to incorporate the correction factor or the temperature correction factor, humidity correction factor to validate the result. Okay. Now, just I want to show you in summary what are the general observations. What are the general observations about how you can interpret periodic insulation resistance test and what you should do with these results. So these are the condition, and you have to do certain thing depending on the condition. So first one is you see fair to high values, means normally it provides high value and well maintained. So there will be no cause for concerns. But fair to high value, but showing a constant tendency towards the lower value. High value, but that, say suppose if you measure that value is 15 mega ohm. Now, if you measure the value is 13 mega ohm after certain regular interval. Now, if you are measure that value after certain interval, 11 mega ohm, and again if you measure that is say 10.5 mega ohm. So in that way, all the results showing higher values. Okay, but if you follow this reading, gradually it decreasing. Gradually is decreasing in nature. So for that case, you have to identify what is the reason behind that decrement of the insulation resistance value. You have to locate and remedy the cause and check the downward trend. Okay, low but well maintained. And say suppose in certain case you will be get, say that value is 5 kilo ohm and it is maintained throughout the at certain period of time. If you are measure that value is slightly lower value, but it maintaining its constant value. So for that case, you have to know that condition is probably all right. Whether the insulating, maybe there is two reasons. Once the insulating materials after certain operation of time, if the insulator is aged, so that is why insulator is provides that low resistance. And but some causes of low values should be checked. You have to check, take care whether if there is a leakage, permanent leakage path is there or not. So in that way, you have to identify what is the reason behind that low value. Low value, but it may well maintained means that insulator condition is good, but you have to inquire why the value is low. It may be due to that. If you use that insulating material quite for a long time, so it basically offers that low value. Low has to be unsafe. So for that case, you have to clean, dry out, otherwise raise the value before placing the equipment in service. And here fair or high values previously well maintained but showing sudden lowering. So that for that case, make test at frequent interval until the cause of low values is located and remedied, or until the values have become steady at a lower level but safe for operations, or until value becomes so low that it is unsafe to keep the equipment in operation. Okay, so with this I conclude here. That is how you will measure the insulation resistance and what is the interpretation of the result. Okay, so today is up to this. If you have any questions, আনমিউট করে বলতে পারো। বলো অর্ণব, হাত তুলেছো, কিছু যদি বলার থাকে বলো।
স্যার আগের ওটা।
ও
Hello?
আগেরটা, আচ্ছা,
হ্যাঁ,
এখন
হ্যাঁ।
কোনো ডাউট নেই তাই তো?
না না।
ওকে, কারোর কিছু ডাউট থাকলে বলো, হাত তোলো। বিশ্বজিতের কিছু ডাউট আছে?
না স্যার ঠিক আছে।
ওকে, আর কারোর কোনো কিছু যদি ডাউট থাকে, এটা খুব সিম্পল জিনিস, জাস্ট এইগুলো তোমাদের আমি ক্লাস নোট